What are you doing?
I'm taking some ice for cold water.
But this ice is not for drinking. This is for testing.
Testing what?
Come, I will show you. And throw it away.
Okay. Hello and welcome. This episode is all about thermocouples, and we are going to learn how to test the EMF value of a thermocouple. And for that, I have with me our specialist Saud Salim. Good to have you, Saud.
Good to see you, Tanya.
So before we begin with the test, can you explain what is a thermocouple?
Simply put, a thermocouple is a sensor which we use to measure the temperature. It might be easier to show you.
Yeah.
The thermocouple is as simple as having two dissimilar metals. When we join these dissimilar metals at one end, we refer to as hot junction, and the other end, which is separated or open, which is a cold junction.
Yeah.
So when this hot junction is exposed to the high temperatures, then it will generate a EMF or electromotive force at the other end. When we measure that EMF, that will correspond to the temperature which is at the hot junction.
But how do we make sure that the EMF is correct?
Well, it all depends or related to the furnaces behind us. But before that, let's have a look on some of the important data.
Sure.
Yeah.
So what do we have here?
Yeah, you asked me like, how do we make sure that the EMF is correct? So to understand that, we need to know what does it mean by correct EMF. And that is dictated by different standards. For instance, in this graph, is the EMF by ASTM standard.
Okay.
So there are different tolerances or this maximum error that we can allow at certain temperatures, which are represented by blue and red lines. These blue lines are for the standard grades, and these red lines are for the special grades. And for extension grades, is in principle the same material, but we calibrate it up to 200 degrees C only.
Thank you for explaining this, Saud. Can you show me how to measure the value now?
Yeah, for that we have to go to the test bench.
Okay, let's go. So Saud, what do we have here?
So we're gonna perform some EMF measurements, and our colleague Dennis will help us with the measurements. So to perform the measurements, we will pass through a series of different steps.
That sounds very interesting. So can we get started?
Now Dennis will cut to the desired length that we need for the testing. The next step is to straighten the wire.
Okay.
So this way it will be easy to fit the sample into the furnace.
Okay.
So here we're gonna anneal the sample, so if there are any residual stresses which can cause the EMF to shift, so we're gonna remove those ones.
Okay.
These are the reference material that we have. So we know the EMF shift of this material against platinum. So that means this could be used as a reference material. And then we will measure the EMF value that the material that Dennis just prepared against the reference material, and we will see how much it differs.
Okay.
So that will give us the value of EMF that we are looking at different temperatures.
Okay.
So this is a very important step for us. So now we're gonna spot weld these two materials as per standard.
Okay.
So we have this material that we're going to test, and one of the reference material.
Okay.
So this is, in fact, is the point which we referred as the hot junction, or the point at which we measure the temperatures. Now we're gonna bend the cold junction, as I explained before, so that it can go into the ice bucket. So it's just a 90-degree bend. So one end is a hot end, or the hot junction, it's in the furnace, and the cold junction, it's in the ice bucket. So now we have, at one end we have this hot air blowing through this end. So we know the temperature there. And on the other end we have this ice, and the legs are submerged into the ice. So we know the temperature at both the junctions. So this will generate an EMF that we will measure on the multimeter. So here we have another type of heating arrangement, that's a tube furnace. And this furnace can go up to high temperature up to 1200 degrees C, which is the temperature range we need. So the EMF measurements that we will perform here will be sent to the multimeter, And this multimeter is connected to the computer and will send over the measured data to the computer directly.
And is it a special software that we are using to see this?
Yes. The logic that goes to the software is kind of very important part of all of the measurements. In this software, we have measurements from different materials.
Okay.
And this software is actually automatically match the best pairs to
Okay.
give us the best result to get a matched pair for a thermocouple.
And what do we see here? What does the result say?
Yeah, these results these are the tolerances in the EMF that the standard allows. And what we want is that this leg is within this interval or this tolerance limits. But as you can see, like most of the measurements that we have done, they are within these limits.
So Saud, now that we know how to test a thermocouple wire, but what about the other leg?
Well, it depends. If we're talking about the matched pair or a single leg, there are some pros and cons for both.
So can you please explain?
I will explain to come.
Okay, Saud, so tell me more about matched pairs and single legs.
Yeah, for matched pair is that the two legs, they have to act as a couple. And for that couple, the EMF is within the range for the tolerances. That is more cost-effective solution since you can select any two legs if they're matching and you can make a thermocouple. On the other hand, if we talk about the single leg, so what we aim for is to stay in the middle, as close to the middle as possible. So in this case, what happens is it's more flexible for the user to use this type of material.
So how do you know what to buy?
It depends. If you are producing the same type of product at a larger scale or in a high volumes, you would like to go for the most cost-effective solution, which is the matched pair. But if you are working on some special design or special customized type of thermocouples, then you need more flexibility, and that you would like to choose this single leg.
Okay, and in what dimensions are these available?
Yes, so what we produced or what we saw in our lab was this very coarse wire, which is around 5.5 millimeter. And then we draw these wires to different thinner dimensions, which are mostly used at the user end. The most common one is 0.81 millimeter.
Thank you so much for all the information that you shared with us today, Saud. Let's summarize what we learned today. So here are the points to remember. A thermocouple is a sensor for measuring temperature based on thermoelectric effect. A voltage is generated when two dissimilar metals are attached and it is proportional to the temperature difference. And this voltage is called electromotive force. The wire needs to be tested at different temperatures to get the correct EMF value. There are standard grades and extension grades, and there are standard and special limits of error. When buying thermocouples, they are available in matched pairs and single legs. Matched pairs are more cost effective, while single legs are more flexible. And that's all from us today. Thank you for watching. I'm just taking some ice.
Come, I will show you.
What part?